Welcome to aminacademy.com. In chemistry, let us go mini tour of periodic tables. The location of different families of main group elements on the periodic table describe their characteristics, properties, and relate their properties to their electron configuration. Location of metals on the periodic table describe their characteristics, properties, and relate their properties of their electron configuration. Here, the main group element. The elements in the group 1, 2 and 13 to 18 are called main group elements. Here, group 1 and group 2 and 13 to 18, these groups are called main group elements. In main group elements are in the S and P blocks of the periodic table. The electron configuration of the elements in each main groups are regular and consistent. The elements in each group have the same number of valence electrons. That means elements in the same group have same valence electron. That means group 1 element have same valence electron, group 2 have their own same valence electrons like. In main group elements are sometimes called the representative elements because they have a wide range of properties. At room temperature and atmospheric pressure, many are solids while others are liquids or gases. About half of the main group elements are metals. Many are extremely reactive while several are non-reactive. The main group elements like silicon and oxygen account for 4 of every 5 atoms found in our Earth surface. Next, here group 1, that is alkaline metals. Here this group 1 consists alkaline metals. These metals react strongly with water to make alkaline solutions. Then group 2, alkaline earth metals. Here first we will discuss about alkaline metals. Elements in group 1 which are alkaline metals. Alkaline metals are so named because they are metallic that react with water to make alkaline solution. For example, potassium reacts vigorously with cold water to form hydrogen gas and the compound of potassium hydroxide. Because the alkaline metals have a single valence electron, because it's a group 1, they are very reactive in ionizing. In losing its own valence electron, potassium achieves a stable electron configuration. Alkaline metals are usually stored in oil or to keep them from reaction with their oxygen, with the surrounding oxygen and water in the air. Next, alkaline earth metal. The group 2 metals are highly reactive, so they are usually found in compounds rather than a pure elements. The group 2 elements are alkaline. Group 2s are alkaline earth metals. Here we will discuss about alkaline earth metals. In group 2 elements which are highlighted are alkaline earth metals. Like the alkali metals, the alkaline earth metals are highly reactive, so they are usually found as compound rather than as a pure elements. For example, if the surface of an object made from a magnesium is exposed to the air, the magnesium will react with the oxygen and the air to form a compound like magnesium oxide, that is MgO, which eventually coats the surface of the magnesium metal. Alkaline earth metals are slightly less reactive than the alkaline metals. The alkaline earth metals have 2 valence electrons and must lose both their valence electrons to get a stable electron configuration. Next group, group 17, that is halogens. Here is the group 17. Group 17, that halogens are the most reactive group of non-metal elements. The halogens are the most reactive group of non-metal elements because of their electrons configuration. Halogens have 7 valence electrons, that is outermost orbit, just one less of a stable configuration. When halogens react, they often gain 1 electron needed to have a 8 valence electron to fill outermost orbit, outer energy level, because the alkaline metals have 1 valence electron and they are ideally suited to react with the halogens. For example, the alkali metals of sodium easily loses its 1 valence electron to the halogen chlorine to form the compound sodium chloride, that is table salt. The halogens react with most metals to produce salts. Here, this group 1 elements is outermost orbit have one valence electron. Group 17 have outermost orbit have 7 valence electrons. So it easily 1 electron shares to that 7 electrons. So it becomes a compound, new compound produced. So it's easy to create valence alkali earth metals. That is, it is easily, that is group 1 element easily react with halogens, so it becomes outermost orbit becomes 8 electrons. Next, group 18, the noble gases. The noble gas atoms have a full set of electrons in their outermost energy level. They are not easily react with other elements, so they are called inert gases. Here, this last group, 18th group, have outer valence electron is 8, so it's not easily reactive with other elements. That is why it's called noble gas. Here, the noble gas atoms have full set of electrons in their outermost energy level except for helium, that is 1s2. Noble gases have an outer shell configuration is ns2 np6. From the low chemical reactivity of these elements, chemists infer that this full shell of electrons make these elements very stable because its outermost electrons have 8. The noble gas were once called inert gases because they were thought to be completely unreactive, but some with special sometimes it's react with some other metals by arranging special arrangements, like chemical reactions to be created easily. Next, about hydrogen. Hydrogen is the most common element in the universe. Here, hydrogen is the most common element in the universe. It is estimated that about 3 out of every 4 atoms in the universe are hydrogen because it consists of just 1 proton and 1 electron. Hydrogen behaves unlike any other elements. With its 1 electron, hydrogen can react with many other elements including oxygen. Hydrogen gas and oxygen gas react explosively to form water. Hydrogen is a compound of the organic molecules found in all living things. The main industrial use of hydrogen is in the production of ammonia, that is NH3. Large quantities of ammonia are used to make fertilizers. Most elements are metals. The figure shows that is majority of an elements, including many main group ones, are metals. But what exactly is a metal? For example, a diamond usually has a brilliant luster. However, diamond is a mineral made entirely of the non-metal elements of carbon. That means most metals are that is luster, means are shining, but some non-metals also having shining. That is diamond is a non-metal, is also shining outermost, that is outer surface of the metals are more shiny. Conversely, some metals appear black and dull. An example is iron, which is very strong and durable metals. Iron is a member of group 8 and is therefore not a main group element. Iron belongs to a class of an elements called transition metals. Here we will discuss about transition metal. The transition metals constitute group 3 through 12. One of the metals that can use the inner shell before using the outer shell to be bowed. Next, lanthanides. Now further we will discuss about transition metals. The transition metal may lose 1, 2 or 7, even 3 valence electrons depending on the elements with which it reacts. Generally, the transition metals are less reactive than alkaline metals, and the alkaline earth metals are. In fact, some transition metals are so unreactive that they seldom form compounds with other elements. Lanthanides and actinides. Lanthanide is a member of the rare earth series of elements whose atomic numbers range from 58, that is cerium, to 71, lutetium. Next, actinides. Any of the elements of the actinide series which have atomic numbers from 89, that is actinium, through 103, Lawrencium. Further details we will discuss in further videos. We have done. Please subscribe our YouTube channel.